Is it
It's
recording?
like looking in a mirror, right?
Yeah.
Yeah,
When
okay.
you look in a mirror, you see like what you see, but everybody sees exactly the opposite of
Whatever, okay.
what you see.
Alright, whatever.
I'm done, sorry.
Okay. Hello? We're recording Polyatomics. Because you people have been absent again. So we're recording, and then we're going to upload it to YouTube, hopefully. Fingers crossed. Alright, here we go. So, naming and formula writing with polyatomics. Okay? That's what this thing is. Prefix poly means more than one, many, typically, and then atomic is over related to the atom. So, many atoms. Yes? Now, it's not many like a lot. It's usually 2 different kinds of elements. It's sometimes 3. It's not a lot. Like, don't be wigging out on me. Okay? Now, we've got to talk about what a polyatomic ion is. Okay? Remember on the smartboard, there's this part where it gets real super weird, so just bear with me if it starts to look like I'm losing it. Okay? So what is a polyatomic ion? It is a group of atoms of 2 or more elements. That's the poly part. And when we put this group of 2 or more elements together, the net has a charge. Okay? So what we've been talking about so far has been, when we make an ionic compound, the whole point of making an ionic compound is to get to neutral, right? That's why the crisscross, drop, and reduce works, because we're getting to neutral. When we put together a polyatomic ion, what happens is we put together 2 or more elements, and when they get together and come together, the overall is not neutral. Well, what happens then is we've got this thing that's positive, or we have this thing that's negative. It can't stay like that. Things cannot be electrically not neutral, because not neutral is unstable. Okay? So what happens is we have these polyatomic ions that form, then they, as a group of elements, go get together with something of another charge. Okay? These are ionic substances. That's why we're talking about them now. Remember, an ionic compound is anything that is a positive getting together with something that's a negative. Okay? 2 or more elements. 2 or more different elements. Now, we're just going to get into the meat and potatoes of these pretty quick. Okay? There is no avoiding this, and I don't apologize for it because I didn't invent chemistry. Told you that before. Okay? The polyatomic ions, the ones that you need to know, must be memorized. There's no avoiding this. And they have to be memorized. Today is Tuesday. We will take a quiz tomorrow, and you guys will use these. I will give them to you on the quiz. I'll give you like a key, which means they don't have to be memorized by tomorrow. But when we take our quiz on Thursday, they have to be memorized. So you have 2 days to get them memorized. There's only 9. We're going to practice with them a lot. I think you'll be fine if you'll just do it. Okay? Now, the next thing I want to tell you about these. Never, ever, never, ever, never change the subscripts on a polyatomic. Your wanting to do that will not be now. If you change the subscript on polyatomic now, it's going to be by accident. You're going to have written it incorrectly. But when we get into balancing equations, which is not the next unit but the next unit, you're going to want to change the subscript seriously. Because it will inconvenience you that one of them has a 4. It will inconvenience you that one of them has a 3. And you're going to want to change it. You can't. It would be like changing a subscript in the formula for water. If I did not have H2O as the formula for water, I don't have water, right? So when you change the subscripts on something, you change its identity, okay? So you cannot ever alter these at all, ever. And I'm not going to come back 2 weeks from now and tell you different and say, oh, I said never, but then there's the one time. I'm not going to tell you that, okay? Does anybody need this? Alright, now, I'm going to give you the list of polyatomics. You need to write them, please and thank you, into your notes exactly the way that I have written. I'm going to give them to you like in chart form. Okay? So you need to get them written exactly this way. Some of you are going to want to memorize them this way, and some of you are going to want to be able to recreate this chart onto your scrap paper when we take a test, when you take the SOL test. Okay? I'm not telling you have to, but it would not be terrible if you did. We will have 4 columns, by the way, just so you know how big to make it. We have one polyatomic cation. Remember, cation has a positive charge. We have one. It is NH4. It has a 1+ charge. Its name is ammonium. It is the only polyatomic cation. All the rest of them are anions. Our first polyatomic anion with a -1 charge is C2H3O2. That is called acetate. The next one is NO3. Named nitrate. Next is OH. This is hydroxide. The last one is HCO3, and it has 2 names, and you may use either. There's one that I use. There's one that most people use most often, but it does have 2 names, okay? HCO3 is bicarbonate, which is the name that most people use, including me most of the time. The other name, we'll say AKA, hydrogen carbonate. Did I say we had 9 of these?
Yes.
We have 8. Alright. Our first polyatomic anion with a -2 charge is CO3, which is carbonate, which is not the same thing as hydrogen carbonate. It's not. We also have SO4, which is sulfate. And lastly, we have one polyatomic anion with a -3 charge, and that is phosphate, PO4. Now, we're going to practice this right now. We're going to take these, we're going to start naming with them, we're going to start formula writing, we're going to crank them out. Okay? So I'm going to show you guys that in just a second. Let me give you a little tip in terms of studying. Okay? Number one thing I want to tell you, we're taking a quiz tomorrow. Tomorrow's quiz will be just like today's quiz and yesterday's quiz, except that it will include these. At the top of the quiz, I will give you a chart that says this. Do you understand? So I will say to you, if I want you to do on the quiz some chemistry with ammonium, I will put NH4, ammonium, and I will tell you it's a 1+. Do you follow? So I'm going to tell you all that on tomorrow's quiz. And then I'm not going to tell you again. I'm not going to give you that information again. You have two options that I would suggest in terms of studying. One is what I already mentioned, be able to recreate this list. The second would be, and you could do both of these things, that would be super smart, is to make flashcards. 8 flashcards. On one side, you have the name. On the back of the flashcard, you have the formula and the charge. So, if I was going to make flashcards and I was making one for ammonium, I would have ammonium on one side. This would be front. And on the back, I would have NH4 with a 1+. Do you follow what I'm saying? You have to know the name, you have to know the formula, you have to know the charge. Frontwards and backwards. Okay? So you could make 8 flashcards. And we will maybe get to a point during class, maybe, where you could get some flashcards of mine and make some for yourself. Okay, you guys are welcome to those anytime. Okay, I need to erase this so we can get going. Does anybody need this? Keep this handy because you're going to refer to it over and over and over again. Okay. Naming. If you had to guess, what do you think the order would be?
Cat Island.
Yep.
Followed by An Island. Prince E.
That's an H.
That's an H.
Totally. Change. Do not. Think about that, please. Prior to today's class, if you were doing chemistry and nitrogen was the anion, what would you call it in the compound? You'd call it something what? Nitride. Yes? Which means that it is nitrogen, the element. We now have a polyatomic ion called nitrate, which is NO3, which is not N, it's NO3. And so if we're doing chemistry with nitrate and we call it nitride, we've eliminated the O3 and we've made it just nitrogen. Do you follow what I'm saying? Okay? So you can't change the ending of these. If it's an 8, you leave it alone. If it's hydroxide, which is the only polyatomic ion that ends in IDE, you leave it alone. Okay? All right, one more rule. One more thing I want to tell you, and then we're just going to do it. It's the best way. All right. just using polyatomic ions. We're going to crisscross, drop, and reduce, but we're going to use parentheses whenever we're going to have more than one polyatomic. I'm going to show it to you. We're going to do it. We're going to take some good, nice baby steps. Most of the time, the need to use parentheses will be clear. There's a few times where it's a little sketch, so you got to always be thinking about it. But a lot of times it'll be really clear. Okay? Does anybody need the screen? All right. Best way to learn how to do it is to do it. So here we go. That might be a hard one to start with, but we'll get over it. Have out your periodic table, have it handy. Have out your chart that has all the polyatomics, have it handy. You need both, okay? So, we're going to write the name and we're going to write the formula. So, name is cation followed by anion. Don't change the ending to IDE if we're dealing with polyatomic, which we are. All of these have polyatomics, that's why we're doing them right now. Okay? So, tell me, what is sulfate's formula? Let's just establish this. SO4, and what's its charge? Good, 2 minus. What's calcium?
Positive.
It's Ca with a
2.
2 plus, okay? I'm just making some notes right now. Now, we need to name this thing. We always start with the correct name. So, who is the cation?
Calcium.
Calcium. Don't capitalize. The anion is sulfate. We're not changing the ending, because if we did, we'd make it just sulfur. Okay, so calcium sulfate. That's the name. Done. Done with the name. Now we need the formula. Focus. Pay attention. Calcium is Ca with a 2 plus. Sulfate is an SO4 with a 2 minus. You with me? Criss-cross. Ca2. Now, is there a reducible ratio? This is a 2-2 ratio. 2 to 2 goes down to what? 1 to 1. Okay? So, Ca SO4.
So we never touch what's inside the parentheses.
Correct, because that would be changing the subscript of the ion. Did you guys hear his question? She said, so we don't ever touch what's in the parentheses. That's correct. Don't be messing up in there.